Hello and welcome. In this series, you'll learn how to use condition nodes to create smarter characters and more dynamic scenarios. In today's tutorial, we'll focus on detecting whether an MD prop is occupied. MD props have position points, where a character can stand and interact, and for portable props, placement points, where objects can be picked up or placed. A position point is occupied when a character interacts with it, and a placement point is occupied when an object is on it. Accurately detecting both is key for reliable simulations. First, navigate to Content Manager, Project, MP Set, and locate the embedded MD Props content pack. In this free resource pack, we've included several planning sets that are ideal for demonstrating the logic-aware system. For this tutorial, we'll use the Break Room Planning set. Click Done to load the set into the scene. In this planning set, you'll notice a vending machine, which is a perfect example for explaining how the check position point node works. Let's start the motion director to see the result. You'll notice that some characters will walk to the vending machine and buy a beverage. When there are multiple characters, they will line up and wait. This is where the magic of check position point comes into play. To better understand how this works, let's open the motion planning node graph. Here, you can see 4 group nodes representing 4 characters. Since they all share the same workflow, we only need to customize one as a showcase. Let's focus on Dummy M2. There are several nodes responsible for checking whether the character is indoors or outdoors, allowing different behaviors to be triggered accordingly. The details will be explained in the future tutorials. When indoors, the character performs indoor behaviors within this subgraph. When outdoors, outdoor behaviors are used instead. In our case, using the vending machine is an outdoor behavior, so let's double-click the outdoor subgraph node to examine the workflow inside. At the very beginning, there's a random node that allows the character to decide whether to use the vending machine or wander around the outdoor area. At the end of the workflow, the character will also randomly decide whether to go indoors or not. For now, let's focus specifically on how the vending machine logic works. Here, you can see the check position point node. When you click on it, the attribute panel displays the node's settings. The MD prop is set to Use Vending Machine, allowing us to check whether the vending machine is currently occupied by another character. The position is set to Any, meaning that if any position point under this MD prop is occupied, the condition will evaluate as true. When the vending machine is not occupied, the logic flows through the false output, which leads to the Use Vending Machine action since it's available. On the other hand, if the vending machine is occupied, the logic flows through the true output and leads to a second check position point node. This node checks the occupation status of the GetInLine MD prop. This GetInLine MD prop is placed behind the vending machine, simulating how people wait in line in real life. If this position is not occupied, the logic proceeds to the GoTo node, sending the character to that position point. From there, the character will repeatedly check whether they can move forward to use the vending machine. Now we can start tweaking the setup to create different workflows. Currently, we only have 2 position points for waiting in line: Use Vending Machine and Get in Line. What if we want more people to queue up and buy drinks? Simply duplicate the GetInLine MD prop by holding Control and dragging it with your mouse. This adds 2 more GetInLine MD props to the scene, perfectly aligned for characters to form a longer queue. Next, let's return to the node graph and make a few adjustments. First, remove any unrelated nodes that might distract the character. Then, connect the Start node directly to the first check position point node. This ensures the character enters the vending machine workflow right from the start. Now, we just need to duplicate the waiting in line logic. Press Ctrl+D twice to duplicate the nodes and align them properly. Then, update the MD prop targets. Select the nodes, right-click, and open the Swap MD Props menu. Originally, these nodes target the GetInLine MD prop, Simply swap them to the duplicated MD props in the scene. Repeat this process for the remaining nodes. Now, connect the logic so that when the second waiting position is occupied, the character checks the third one. If it's available, the character moves to that position point. This logic can be extended indefinitely. You can add as many waiting positions as you like. Just remember to connect the workflow back to the previous check position point so the character can continue checking whether they can step forward. After a quick adjustment to the group nodes, this character is ready. Return to the base level. At this point, all we need to do is duplicate the outdoor behavior we've just set up and apply it to the other characters. You can rename the subgraph nodes for better clarity. Then, right-click each subgraph node and choose Swap Actors. The current actor is Dummy M2. Simply switch it to the appropriate character for each workflow. Assign them as Dummy F, Dummy F2, and Dummy M. Once you enter these subgraph nodes, you'll see that everything is already configured correctly for each character. Now we're all set. Start the motion director again, and this time you'll see multiple characters approaching the vending machine and waiting in line. This process can continue indefinitely, and you can apply the same logic to create many other interesting and dynamic scenarios. Next, let's take a look at how check placement point works. You can open MP Set Factory, which includes the transport floor planning set, a great example for demonstrating the logic system. This planning set simulates a logistics workflow. Sorters lift packages from tables and place them onto carts or pallets. Then, transporters and automated forklifts deliver the packages to the storage center. You'll notice that the sorters are able to detect whether there are still packages on the table and repeatedly pick them up. The green sorter places the packages onto the cart, while the pink sorter places them onto the pallet. Once a cart or pallet is filled with 3 packages, the transporter or automated forklift will begin transporting it. These behaviors are all driven by check placement point. Let's open the motion planning node graph again to examine the workflow. We'll first focus on this group node, which represents the workflow for the 2 sorters. Enter one of the sorter subgraph nodes. Here, you can see the check placement point node. Click on it to view its detailed settings in the attribute panel. The MD prop is set to Work Area Begin, which represents the long table filled with packages. This node checks all placement points under this table to see whether they are occupied by packages. The placement option can be set to Any or All. When set to Any, the condition is considered true as long as at least one placement point contains a package. Therefore, when the table has packages on it, the condition evaluates as true and flows to the output that triggers the second check placement point node. This second node checks whether the cart is full. Notice that its placement option is set to All, meaning all placement points on the cart must be occupied for the condition to be true. If even one placement point is empty, the condition evaluates as false. After all conditions are checked, the sorter will pick up a package from the table and put down the package onto the cart. This workflow forms a loop, so the sorter will continuously repeat this process until all packages are transferred from the table to the cart. If the table is empty, or if the cart is already filled with 3 packages, the sorter will enter idle mode and perform other behaviors. Now, let's return to the base level. This time, we'll focus on the transporting group node, which includes the workflows for the transporter and the automated forklift. Since these workflows are very similar, we'll focus on the transporter as an example. This workflow is divided into 2 parts. The first part describes how the transporter reacts to the number of packages and pushes the cart, so let's focus on this section. The first node here is also a check placement point. The transporter checks whether the cart is fully loaded with packages. The placement option is set to All, meaning all placement points must be occupied for the condition to be true. When the condition is true, the transporter will engage with the cart and push it to the storage center. If the cart is not fully occupied, the transporter will remain idle and perform other actions. In real production environments, factory pipelines can become much more complex. For example, instead of having just one table, you might want to add a second table to the factory. Let's attach 3 packages to a new green table and quickly set up the scene. Now, each table has 3 packages, and we can adjust the positions of the 2 tables. In this scenario, we want the green sorters to pick packages from the new green table, while the pink sorter continues picking packages from the original blue table. How can we achieve this? Enter the Sorter1 subgraph node, which represents the green sorter. We only need to change the target of the original check placement point node to the newly created green table. Work area begin 2. This works thanks to the check placement point, which detects anything attached under the target. Also, update the pickup target to work area begin 2. That's it. Now you'll see that the 2 sorters are picking packages from different tables, while the logic continues to work seamlessly. The green sorter will pick packages from the green table, while the pink sorter continues to pick from the original blue table. Now, what if we want to increase the number of packages in our factory? Simply duplicate the package by holding Control and dragging with your mouse. Remember to also duplicate the placement points on the cart so the capacity matches. There's no need to modify the node graph because it is designed to check the root layer. Any object placed under that layer will be detected automatically. You can add as many packages as you like, and the logic will continue to function correctly. In this example, the green sorters will move all 4 packages onto the cart. Thanks to the powerful check placement point function, the sorters know exactly how many packages remain on each table. And the transporter will engage once all 4 packages are placed on it. Finally, what if we want to change the transporter's behavior so that it pushes the cart as soon as there is at least 1 package on it, instead of waiting until all placement points are occupied? Enter the transporter subgraph node and click on the check placement point node. As mentioned earlier, the placement option is set to All by default, which causes the transporter to wait until the cart is completely full. Simply change this option to Any, and the behavior updates immediately. With just 1 package on the cart, the transporter will now engage and push it forward. By combining check position point and check placement point, your characters can accurately understand both character interactions and object availability in the scene. This allows your logic to stay reliable, scalable, and responsive even in complex simulations with multiple actors and props. That's all for today. Thanks for watching.